All right, here's AP style titration free response problem 2. This curve represents the titration of 25 milliliters of 0.1 molar acetic acid, Ka equal to 1.8 times 10 to the minus 5, with 0.1 molar sodium hydroxide. A, label the equivalence point, half equivalence point, and pH at the equivalence point. Circle the buffer region on the graph. And B, explain how the pH of the starting point and the volume at the equivalence point would change if the analyte were changed to be 25 milliliters of 0.2 molar acetic acid instead. So what if we increased the concentration of the acid? What would happen? All right, so in blue, here's the half equivalence point, the volume and the pH. In green, here's the equivalence point and the pH at that point. And in red is the buffering zone. So the half equivalence point is at 12.5 milliliters of NaOH. At this point, the pH is about equal to the pKa, 4.75, and the concentration of acetate and acetic acid are equal. The equivalence point at 25 milliliters is at a pH of about 9, and that's when all of the acid is neutralized by the base. And again, this is our buffered zone. This is where we have some acetic acid and some acetate, which allows for some buffering to occur. All right, so finally in part B, we're asked to explain how the pH of the starting point and the volume of the equivalence point would change if the concentration of the analyte was 0.2 molar. So the same 25 milliliters, but double the concentration of what we were working with in part A. So this black curve here is the original curve from part A. Okay, use my mouse. This one right here is the original curve from part A. Let's take a look at what happens in the red curve, which is what you get by using 0.2 molar acetic acid. So the 0.2 molar acid analyte will have a slightly lower pH, and that's because the pH is the negative log of the hydrogen ion concentrations. And that will be slightly larger if we have a slightly larger concentration of acid. So the pH will be lower. The 0.2 molar acid, which is on the red curve, starts then slightly below the 0.1 molar black curve as its pH, starting pH, is less. And then also the volume at the equivalence point for the 0.2 molar analyte, it's 25 for the 0.1 molar analyte, and it's 50 for the 0.2 molar analyte. And that's because it requires more base, twice as much base, to neutralize that doubly concentrated acid. So that's what we would expect from increasing the concentration of the analyte acid and keeping the concentration of the titrant base the same.